Pleasant morning, everyone. When you run a part of the relay and pause on the baton, there is no sense of unfinished business in your mind. There is just the sense of having done your part to the best of your ability. That is it. The hope is to pass on the baton to somebody who will run faster and run a better marathon. I wholeheartedly welcoming you all to the spectacular second day of an amazing international conference on machine learning and data analytics for business decision making. Now, I request Bavadarani from MBA to introduce our extraordinary speaker, Dr. Manjunath Ramachandra Iyer. Over to you, Bavadarani.
Dr. Manjunath Ramachandra has a blend of academic and industry experience over 25 years in the verticals of healthcare, telecom, and consumer electronic, spanning the technologies such as signal and image processing, artificial intelligence, cloud computing, IoT, wireless communication, and quantum computing. He worked for the companies such as Tata Consultancy Services, Royal Philips, and currently placed in Wipro Limited. He has filled about 90 patents, authored 210 research papers in international conferences and journals, and a book. He was a member of Embedded Systems Special Interest Group at NASCOM and advisor for consumer lifestyle and healthcare subcommittees. He represented the industry in international standardization bodies such as Wi-Fi Alliance, served as the editor for the regional profile standard in Digital Living Network Alliance, and as the industry liaison officer for the CE Linux Forum. He is an active member of IEE standardization activities on industrial AL. He is also a member of the work group of standardization in trustworthiness, digital rights, and ethical standards at in AI Department of Telecommunications India. He has delivered over 24 keynote speeches and conducted over 21 workshops and tutorial sessions. He has worked as a senior faculty, visiting professor, and advisor for various institutions of Viveshwaraya Technological Universities. He figures in Marquis Who 2008 and 2000 Outstanding Intellectuals of the 21st Century. International Biographical Center UK. His areas of interest includes deep learning, artificial intelligence, signal and image processing, and wireless communication. Now he is here to share about AI and machine learning real-world applications. Welcome you, sir.
Thank you. I will share the screen.
Sir, you can share, sir.
Yeah, sure. Is it visible now?
Yes, sir. It's visible.
Thank you. Good morning, friends. I'm very happy to be a part of this conference and share my little experience in the different verticals of artificial intelligence and like how they are being used. I will try to take you to a different world for the next 40 minutes or 45 minutes where the machines will really work for us. You may be wondering what the machines can do for us. Can the machines replace me? Can the machines attend the conference on my behalf? Why not? Maybe one fine day you can have your agents or your dummies or proxies instead of yourself being in the attending the conference. Yeah, that is also a very good use case for the artificial intelligence, like representing yourself, a machine representing yourself, a machine knowing what you want, a machine knowing what you are supposed to learn. If a machine can tell, hey, at the end of the conference, if you have now you don't know these many things which have been told in the conference the entire day, and you know certain things, you don't know certain things. These are the things which you are supposed to learn. The machine can listen to those things and reproduce those things to you at the end of the day and sync up with you. Why don't you do that? Really, it can be done. Maybe that requires high-end AI. And in fact, Facebook has already tried such things. It may not be for the conference, of course, for the business. The business negotiations are very tough sometimes, right? Nobody will be able to budge because they will always be thinking of the profit and loss. It has to be optimal for both the parties. So instead of people, the experts being a part of the negotiations, they will put the machines which have learned artificial enabled machines for negotiations. They do business negotiations on your behalf. And at the end of the day, we give the transcript. So it's up to you to accept it or not. Yeah, such things will be coming. And last but not least, the presenter can also be represented by his own avatar or his persona, what I call it as. Instead of me speaking, we are giving the lecture or conducting a guest speech. A machine can do that, and it can even answer the question the way I do that. right? The machines will learn the things. The important thing is machines should learn all these things over a period of time. We will see how that learning happens. So I will take you through some of the applications of machine learning. Initially, we'll see the algorithms, like what type of algorithms are popularly used in artificial intelligence and machine learning, and how they are used in different domains and spanning different applications of the industry, different applications of the consumers and the like. So what is artificial intelligence? You may be wondering, even we have intelligence, what type of intelligence machines can have? Is it too artificial kind of thing? It is artificial intelligence, nothing but a machine will be learning certain things from the known norms or known procedures and starts emulating that and applying that. That's all about artificial intelligence. So whatever you have in your head, the different the ways of doing the thing, it can be the recognizing an object or recognizing a certain sound or reading certain language or different capabilities, right? These capabilities have been imported or been transported to machines, that the machines will try to mimic or imitate the human beings as if they have the intelligence. So as a part of that, machines do start negotiations, as I said, machines do start conversation with each other. Can a machine talk to another machine? How nice it would be. Have you ever seen or got an opportunity for a machine to machine speaking with another machine? Yeah, you can really write such programs in AI. And in fact, Facebook did that. So it went out of control after some time. The machine started speaking in their own language, which human beings could not understand. That's when Facebook got really scared, because we don't know what they're conversing, and we don't know the consequence of their discussion, and we don't know what they're going to do next. Of course, they may not do they may not jump out of the world and they may not harm you, but they may take unprecedented control, generate unprecedented control signals. They may block the entire internet, right? They may put viruses into the network, and they may corrupt your devices. That type of unit they may acquire. We don't know that. So it immediately aborted that project itself. So over intelligence of the machine or uncontrolled intelligence of the machine is always dangerous. That's what I'm trying to bring in. So here is a data dump. You have so many devices around you, right? You want to, how do you get data? What do you do with the machine intelligence? You have to control certain devices. Or you have to ensure that certain decisions have to be taken on your behalf or certain actions. So there are so many devices, so many objects and animals are many things around us. So we have to take decisions or perform certain actions. So they all generate data. The bread and butter of artificial intelligence or machine learning is the data. So they all generate the data. So we have to use the data effectively initially to train the machine. Machine itself will not know anything. It's a dumb device. So based on the data or patterns within the data or information contained within the data. So we have to do some analysis over that, like what patterns are there. If this is the input, that is the output kind of thing. So that you may be wondering, why don't I use lookup table? Suppose 2 into 2, you may be table set multiplication tables. 2 into 2 is always 4, right? So if 2 into 2 is given, the system can give it an output as 4. So if it is so deterministic, then why do I need artificial intelligence in that? The real world is not so. The input in a lookup table or in such multiplication tables or whatever the tables, you can store only a certain number of things, items which are known. What if an unknown sequence of input is coming over there? What if some other number, say 2.4 into 4.5, some number is there which is not there in the integer tables? If that is the input given, what should be the output? That's where the artificial intelligence comes into picture. It has to take certain decisions. Such inputs are called as noisy inputs or unseen inputs or untrained inputs. You don't find them in lookup table. You don't find them in the data to which the system has been trained. If that is the only case, then you don't need artificial intelligence at all. You just need your tables. You can always use the output. That is also a part of course, intelligence that is used in fixed kind of computing that we are always familiar, right? That's also an important aspect. It's not that it's information. It is unimportant. So the whole concept of AI is it will take the unseen input and it will generate the appropriate output. That's what an important thing is. Suppose I give my face for you to recognize. Then a machine will recognize the face. Only if I have that kind of face. Means if I grow beard, for example, it will not be able to recognize. because it looks at a different face. If it tries to do pixel comparison, then you will find that the images are not matching with the actual person. So that's what a fixed program will do. But in machine learning, it is not so. It will not look at the face, the pixel values or the color of the face. It will actually look at the features. Is this an old man? Does this man has white colored mustache? Those kind of things it will do. And we will look at the things a little later. So the important thing is we have so many things around. They'll all generate the data. They'll put the data into the cloud. And on the cloud, you have a lot of data, historical data, like what we call it as big data, and that data is shared by your artificial AI programs, which are also sitting in the cloud. So this is one ecosystem, one AI-based, typical AI-based solution. It's not that every solution should make use of cloud. It is also possible to put the AI solution in your mobile phone also, in your computer also, and go ahead with that. But typically, an AI system takes the data from the IoT devices through the IoT devices and streams the data to the cloud where the processing happens, and a lot of data is there, will be there, historical data used for training your models, AI models, to build the models, and it takes the data and gives the inferences. That's what these IoT technology, cloud computing, big data, and the artificial intelligence, all these four technologies are actually going hand in hand. There is the convergence of technologies. The important aspects of artificial intelligence are learning, inferencing, interpretation, and thinking. There is a kind of evolution happening over there. Means learning systems. What do you mean by learning? For learning, you need to have some reference, some books. How do you learn the things? You will have some books. You will go to visit the books, or you will get some documents and read that and learn, right? That's how a system also does. A machine intelligence system also does. It will acquire the data and it will start learning. It will get trained itself with the data. Then it will start inferring. When new data is coming, then it start approximating the data. So these are the things. It is close to that. Although I have not learned like this, so you will not learn the things word by word, right? You will have some vocabulary. You learn certain language. It may be your mother tongue, or it can be English, or whatever it may be. Then you will not learn every line by line of every document, right? Based on your language abilities, you can read any document, for example, given in English, right? That's how the system also does. And it will start inferring from that. Means it will start classifying. When I say inferencing, it will do certain activities such as classification or object detection or word identification and or prediction. Suppose the things are moving like this, are behaving like this in the historical with the sequence. What should be the next sequence? How it will be behaving after some time? That you will be able to predict it based on the past observations. Then the last level of intelligence to the machine is thinking. That's what I was telling about the Facebook thing. They will be able to think, meaning based on the previous experience, machines will be able to think like human beings. Based on the experience, based on the so much of knowledge. So knowledge is the prerequisite for thinking, because with that knowledge, with that acquired information, you will be able to tell or start giving advices for the different contexts or similarities in the situations. So such things are called decision support systems. Means it doesn't mean that the machine should be replacing the humans, but they will be augmenting the humans. For example, in the healthcare also, with all these symptoms of your disease or disorder, you can tell it to the machine. Then the machine will start churning the data. And based on the previous histories, case histories, it would have studied hundreds of such people. It would have made studies on thousands of such people's health records. Then based on your symptoms, it will be able to give a proper diagnosis. It does not mean that you have to go to that machine always or replace the doctors. So it will help the doctors. It will give a second opinion for that. That's how we can make use of the AI systems. So effectively, the AI components fall into these four parts. One is, of course, object detection, right? Whatever they capture with the camera, so the machine should be able to identify that. Then only it can act upon that or take decisions upon that, right? So first and the foremost thing is object identification or the object detection. The next part is the word detection. Since we also process the languages, the word detection, it has to understand the languages. Then only it will be able to do many such things, such as machine translation, language translations. Probably you might have used Google translations, right? On the document translations. So these things are possible. It's with the built-in the ability to analyze the words. Words are the vocabulary. So you can blend the two also. For example, you can see certain objects and start commenting on that. A machine can do that easily because it would have learned to identify the object, and it would have also learned the vocabulary or the language, at the dictionary of the particular language, and it will start commenting. If somebody is walking, it will be able to say he is walking, kind of thing, because it will be able to associate those actions or the frames, the video, the image frames in the video with the corresponding actions. It would have been trained to do that. When I say training, we will see that formally. A neural network can be used as the building block to train such things, means to such learnings. And that when you feed data to that, it will be able to tell what the particular action is. And the third important application is the regression. So when I say classification, it is a hard-coded bins. For example, if you have to classify a certain person as a child or a middle-aged man or an old man, kind of thing. So these are the three bins you can put. But in the regression, if you have to give the age of the person also by looking at the photograph, machines can to an extent do that. Actually, there are online tools also, which if you put your photograph, it will give you the approximate age, right? So that is a regression problem. Means the numbers are continuously running. You can have the output as a continuous number rather than as a fixed number of bins. And the fourth important thing is association. This is an important aspect, especially in language learning. So it will be able to associate the words to certain emotions. For example, how bad it is, if I say, then it will associate it to the bad mood, unhappy mood, unhappy sentiment, kind of thing. So such things are association, means they are associated with certain outcomes or the activities. Some words are actually associated with certain outcomes. Or among themselves, some words are always coming together. This is, after this, the next word is in most of the cases. Such association will be there with some probability. It doesn't mean that always every word following next to this is always is, or English is, right? It need not be so. But in most of the cases, that is the case. So corresponding probabilities are assigned. Coming back to the way of learning in artificial intelligence, suppose you are finding here. It is me, of course. So if you find the picture here, and if I drop in front of you, we'll be able to identify, right? How do you identify that? First you will see, is this a gentleman, an old man or not, right? You will put a tick, old man. Then you will come to the facial feature. First you give the overall feature. This is a gentleman, this is an old man, the tick is done. In the next page, you will find the face. Is this gentleman having white mustache, right? Then you start putting the tick. Like that, you start putting that. Is he having a square face? Like that. You start putting the features one by one. So at the end of the thing, you will be taking a decision. You will see all these features together. This is my hair, my face, right? My shape of the face. All these things will be affecting to take a decision. Then you will find out, oh, this is Mohanasundaram, right? Like the same way, the systems will also learn. AI systems will also learn. So they will learn step by step or stage by stage, right? That we'll see in the next slide, of course. The important thing is in AI, you will, as I said, you will not be using the fixed images, right? If you use the curve image, and if I find another curve and start comparing with the curve image here, that the curve what we see there may be totally different. If I start comparing the pixels, we will not be able to say that this is really a curve. So it has to capture something else other than the pixels. So it has to find it has to capture the features. Like I said, the mustache or the color of the mustache, that kind of things. So it has to capture those features. Then only we'll be able to take the decision. So effectively, artificial intelligence has two components. One is to capture the features or the patterns. Second one is to take a decisions or inferring based on the patterns or the features. These two things will always be there in any AI system. So the leaf nodes of the AI system are, as I said, artificial neural network, ANNs. So they contain, the input is ingested into these systems, AI systems, or the ANNs, artificial neural networks. These inputs are weighed. The weights are important factors here. These inputs are weighed. For example, if X1 and X2 are the inputs and W1 and W2 are the corresponding weights, then I will get an output equal to W1 X1 plus W2 X2. They are just weighed and added together. And after adding that, they are passed through a non-linearity. That some non-linear function. That non-linear function could be sigma function, or it could be a hard-coded kind of a signum function, where if it is more positive, take it as 1. If it is negative, take it as 0, kind of thing. Right? The weighted sum can be anything. The input can have any values in that. So the output will be, an output will be generated from this neural network. Like that, it continues. This will be fed to the input, ingested to the input of another artificial neural network. Like that, the chain goes. So, and the ANNs are the fundamental building blocks of your AI system, I can say. So, coming back to the learnings, there are different ways of learnings. So, one is the analytical learning. As I said, you can use a lookup table, and if an input is given, you can always generate the output, or you can use an equation, analytical y is equal to mx plus c, kind of thing. So, the challenge here is, let us take an example. There is a dog here. We have to make the dog to walk along a straight line from point A to point B. So one is to give the coordinate. Suppose the dog is standing at point x1 y1. What is the next coordinate to make it as a straight line, x2 y2? That you can always use the equation y is equal to mx plus c, or you can give a list of coordinates to the dog to follow that path and go along the straight line. That is one way of learning. Right. The next other way is unsupervised learning. Means we will leave the dog at point A, and we will tell the dog to, and say that, hey, you don't go beyond these 2 railings. We'll put some 2 railings, and we'll leave the dog. The dog will always be moving within the railings to a great extent along a straight line. It need not be a perfect straight line, of course, but it will move along a path, along a straight path. The third method is supervised learning. In supervised learning, what happens? We'll give the pictures of the road to the dog. Hey, these are the pictures. You have to follow this. These are the railings. You have to walk on the railings. Then you can say the dog will take the picture and it will start walking on the same railings. Right. The fourth one is very interesting. That is the reinforcement learning. Probably I'll try to play the video. Not sure if you are able to see that. Okay, so this is how the dogs are trained. Probably you would have seen that dog trained to bring the ball when it is thrown at some distance, right? So here the dog, what the trainer will do, every time the dog does the work, whatever he says, he will start rewarding that. So you will give some reward to that. Say a bone to that, a fish to that, then the dog will be very happy and it will start listening to the person. So in that case, the dog will learn to go. If the dog runs along the straight line, if you start rewarding the dog, then every time it will start running in the same straight line. That is the reinforcement learning. These are the 4 different types of learning. The important thing is, in supervised learning, you need a lot of data to tell the dog to go along this type, right? The input images are required to be provided. But in unsupervised learning or in reinforcement learning, you don't have to give that many data points. We'll see that very shortly. So coming back to the different architectures in AI, whatever we use, the first thing is the long short-term memory, LSTM. Probably you would have heard this term. What is long short-term memory? Is it not contradicting what is long-term memory, short-term? You may be wondering. So these are the chunks of, suppose I say, imagine your mother or grandmother giving you a cup of coffee. So if I tell that, then you will start remembering the days or some incidents where your mother or grandmother would have given coffee. So you'll be able to recall or recollect the full incidents of getting coffee from your mother or grandmother. But that would have happened so many years back. But this is short memory in the sense short duration memory, which would have happened so many years back, right? So several such incidents will be remembered by our brain. The same way, the network can also remember. Suppose an entire textbook is fed to an LSTM network. It will start remembering certain items, certain keywords. Suppose you want it to remember certain keywords, right? It will be able to remember that through the method of training. Then if you start firing over those keywords, then it will be able to generate the answer also. That's the beauty of LSTM network. So essentially, it will be useful for handling the sequential data. Means, as I said, the textbook data, for example, coming where the words are coming one by one, one next to the other. The other type of network, what we use in deep learning or in the artificial intelligence domain is convolutional neural network. You may be wondering what convolutional neural network is. So this is close to the example what I gave, the mustache example what I gave. So if you have the book at the template, which had the facial features, right? In the first page, as I said, you had the features of the person itself, the age of the person. Next, in the next page, you have the facial features. Within that, you have so many features, like the type of the shape of the face, the color of the mustache, so many things. Here also, convolutional neural network exactly does that. So the templates, whatever I said, are generated using convolution operation. They are applied over the image, and it will start generating the features one by one, layer by layer. There we used page by page. Here it generates layer by layer. So this exactly it looks like. Each layer is maybe thought of as a kind of pages, what I said there. And each of the features are generated there are similar to the feature generated by the convolutional neural network. That's how you can identify the person also. Sorry. So convolutional neural networks can be used, or even their variants can be used to identify persons, face detection, for example. That can be achieved with convolutional neural networks. So as I said, there is a level of abstraction starting from the person, then to the face, and within the face, it is the mustache color, like that. Yeah. Next, coming to some of the applications of the CNN. CNN itself is used for many applications because it will be able to identify the objects, like the way we identify the face. Sorry. So, it can be used for scene parsing. Given there will be so many objects within a scene, right? When you take a photograph, you will find so many objects. So, so how do you identify each of these objects? That can be done in then making use of convolutional network. The network would have identified each of the objects separately. It would have been trained because each scene can contain different objects in different combinations. So a convolutional neural network should be able to identify all these objects individually. It is then it will be able to identify any scene and it will be able to tell this is the bag, this is the book, all this kind of thing. The other application is video description. Here the boy is playing a golf. Boy is playing golf here. So the system will be able to identify this because the system can identify the ball, it can identify the golf court and the snooker, I mean the bat and other things, and it will be able to tell what the boy is actually playing. So the LSTM network, as I said, it is able to generate these text data. The other application is pattern matching. Suppose if it is required to diagnose the different disorders, you would have taken the image of the eye. Here, how an ophthalmologist will be able to identify certain disorders in the eye, such as diabetic retinopathy. When retinopathy happens, there will be some spotting happening in the retina images. So the system will be able to identify it very easily. When it comes to cancer, for example, if the thermal imagery of a person is taken and fed to a system, well-trained system, in the same way, it will be able to identify the cancer 8 years ahead of any other modalities of diagnosis. For example, CT or MR. 8 years is not a small number. That's why it will be very useful. In the very early stage itself, the cancer may be diagnosed using thermal imagery and the combination of this kind of well-trained CNNs. Because the patterns, it will be able to make out the patterns which the human experts will not be able to do that. The other image what you find here is the car which has been damaged with accidents. Such images can be, such applications are very useful for useful by the insurance department. What the person has to do is he has to take the image of the accident car and he has to upload it. Then the system will be able to assess the damage caused to the car, and also it will be able to give how much of it would have been damaged, and it will be able to tell what is the damaged value also, how much of insurance the person should be given if it is trained properly. The third important aspect is the image generation. So the artificial intelligence can also generate the image. If you give some description from your fantasy, all of a sudden if you start telling, hey, I want to see a blue sky, in the blue sky the white clouds are running, in the middle of the white clouds I have to find an airplane. If you start telling in your own language, the system will be able to generate such images. That is very interesting, isn't it? So how is it possible? The system would have been trained with all these objects. All it needs to do is it has to put them together. Whatever is tell, it should be able to identify the clouds, the blue sky, the airplane, all these things individually it should be able to identify, recognize. That can happen through a classifier. Then to start with, the input can be just a kind of noise, random noise. The image generated is also a random noise from the system. But over a period of time, in iterations, it would have been trying to generate whatever the words you tell, it will be able to generate the corresponding images, right? And every time it will be corrected. When I say corrected, that's the process, that's actually what happens during the training. When I say training, the AI system will be able to generate certain output, and if the golden reference output is not matching with the output generated by the system, then an error is generated. That error will be useful to adjust the weights of the neural network, which I showed a few slides back. Again, when you apply input similarly, then you will be getting the perfect output, nearly matching output at least. So this iteration happens several times, several thousand times. This is the most time-consuming process, and over a period of time, and after so many iterations, if you give the proper input, you will be able to generate the corresponding output. Here also, initially the image generated by the system is just a junk, is just a collection of dots. But this is not what you want. Initially, you would have already shown what the cloud is, but you need the image of the cloud also. It cannot generate the cloud on its own, right? To start with. To start it, you would have shown the cloud. Then from the random noise to the cloud, what the difference is? That difference is used to fine-tune the weights. Next time, when you say cloud, corresponding cloud will be generated. But when you say in a collection of words, there should be a cloud, the middle of the cloud, there should be an airplane, all these things, it would have learned them individually. Finally, it will start generating all these things, right? So it will not be for individual things. It can be any choice of words. Today, may tell it as in the middle of the cloud, tomorrow it can be the edge of the cloud. All it needs is, it should know the difference between middle of the cloud and edge of the cloud. It need not be trained with everything, right? Here is an example for association. Here is a random image. Can you guess what this image is? I feed this image to the system and ask the system to give me the proper image. Let us see. Can you give? This is the image. So if I jumble these the parts in this image, I will get the one in the right hand side. But still, it is not the perfect image. But the system can take this image as the input, and it will, after several iterations through the generative adversarial network which I showed, it will generate the perfect image, like the one in the the bottom right corner. Next we have reinforcement learning. I was telling about the reinforcement learning. Let us see. As I said, can you see the aircraft moving? I mean the helicopter moving. Here the helicopter is moving very dangerously. You may be wondering, who is really driving that? Has it been driven by an untrained person like me? No. Actually, nobody is trying it. Did you observe one important thing? Although it is not moving in the perfect path, in a very dangerous path, which we don't dare to sit in that helicopter, it is not actually hitting the earth. Did you learn? Did you see that? The important thing is it is learning how to drive itself. The only thing it knows is it should not hit the earth, right? And it should be as straight as possible. Over a period of time, it will learn on its own, by its own mistakes. So learning by mistakes. Whenever it does the mistakes, it will be given minus negative marks. When it does a good job, it will be given a positive mark. Like that, over a period of time, its rewards will be accumulated. So eventually it went, hey, this is the straight path. This is the path I have to take. Then over a period of time, it will learn. It will learn to take up in a very smooth way. So that's how the reinforcement learning is. All you need is you need to have a mechanism for punishing it or rewarding it. The same thing is used in many applications, such as the control. Suppose you don't have data. As I said, for supervised learning, you need data. The network, convolutional network, what I said previously, that requires a lot of data for training. The data of the cloud or data of the sky, whatever I said. A lot of data is required. Thousands of points of data for images are really required. But if you don't have adequate data, if you don't have data at all, this reinforcement learning would be very helpful, because this aircraft has not been shown how to fly. Nobody told this helicopter to fly to take this type of path during takeoff. It learned on its own. Only thing it knew is it should not hit the earth, and the path should be as straight as possible, as smooth as possible. So these are the goals. So it's a goal-driven system without any training data. So such things are used in, for example, resource allocation in the cloud data center, because nobody knows what type of resources are required, how the cloud will be loaded at some point of time, because nobody knows it. There is no adequate data to train the system. The system should know on its own and learn on its own, and then start training allocating the resources. So another variant of AI is the multi-layer perceptron. This is just a neural network, what I was telling. It's a combination of so many neural networks. The output of one is fed to the input of the other, like that it goes. So it is used for decision making and resource allocation, like that. For example, if the buffers in the traffic are getting full in your network traffic, then if you start pumping the data, some more data, video data, more and more, then what happens? The packets will be lost. There is no storage to store the data in the network. Then what the system should do? It will start sending a signal to the data sources to pump the data slowly, or to reduce the data rate. In that case, the frame rates can be adjusted. Instead of 30 frames, 25 frames can be sent by the system, like that. So such a thing can be done with this type of network. It can identify the things. So far we have seen some deep learning techniques. We saw the convolutional layers, neural network. We saw LSTM neural network, the multi-layer neural network. Now we'll see the traditional machine learning things. So there is a fine difference between machine learning and artificial intelligence. Of course, artificial intelligence is an umbrella term which covers so many technologies. One of the technologies is machine learning, where the system will learn with some features. In machine learning, the important difference between the machine learning and the technologies, what I said, the CNNs, LSTM, they all come under deep learning. The difference between deep learning and machine learning is, in deep learning, we don't give the feature. We did not generate any feature. We just dumped the input, and the system generated the patterns through convolution or whatever the technique, and the decisions were taken. Here, what happens in a traditional machine learning is, we generate the features. When I say feature, for example, if the input signal is given or input image is given, we start passing it through different filters, low pass filter, high pass filter, whatever. We will start segregating the colors, RGB colors, and we will start passing it through a low pass filter and apply it as an input. Then pass it through high pass filter, apply it as another input. Like all these things we generate it. But in deep learning, we don't do any such things. We leave it to the system. That's why we need a lot of data in deep learning, because the system has to learn everything on its own with the method of training. In machine learning, whatever I'm showing here, which is a support vector, here I'm showing one technique. That is the support vector regression, right? Here what happens, we generate the features. For example, some features are generated here. When I say, for simplicity, I have taken only 2 features, feature 1 versus feature 2. So I have plotted that in a 2-dimensional graph, which are for every data point or every input point, we are generating 2 features. Accordingly, I have plotted it in a 2-dimensional graph. X-axis is feature 1, y-axis is feature 2. So every input can be represented by points. So and I will start writing a regression line here. When I say regression line here, it is the separation within the features. If the features are to the below this line, and if the features are above that line, they are different classes. So, for example, if you have to classify the image of the image into a child or into an aged person, in that case, for example, each dot can be a child. An image cannot be both child and aged person, right? So it has to be distinct. So the line has to pass somewhere in between. If I take an image, input image, that will be represented by a line. I mean by a point. That point can be either above that or below that line. If it is above that line, then I can call it as that image is an aged person. And if it is below that line, if the image is that of a child, and I can take the decision appropriately. Next, another thing is the time series prediction. Probably you would have heard about these things. Suppose you are performing a certain action in a specific way, then you can start predicting it. Next time, how it can be. For example, rain, especially rain. If the rain is for so many years, it rains in the month of September, October, November kind of thing. What is the quantum of the rain? If it has rained so many mm in August, what is the quantum of the rain in September? You'll be able to predict it based on the data, what you have observed so far, right? Such a prediction can be done with the help of these artificial neural networks also. If you know the values up to a point t, the value of t plus 1 can easily be generated. Of course, the predicted value need not be very accurate, but still it is reasonably accurate. It will take care of all types of non-linear fluctuations. Don't think that prediction can be done only if the data is linear or smooth. That is anyway equations can do or formula can do. There is no prediction involved over there, right? So far we have seen some technologies. Now we will quickly get into some of the applications. That is the bread and butter of this discussion. So AI can be used in all walks of life, right? From the conference, what I was telling, to telecom, even to give you personal assistance, even to give you personal advice also, right? So it can be used in all walks of life, invaded all applications. Of course, I will listed a few of them. Due to lack of time, probably I will not be able to tell you everything. So it is being used effectively in telecom, healthcare, consumers, automation, energy, retail, whatnot, everything. So we'll quickly see how it is used in telecom. For example, some of the applications, the most advanced application I will give. For example, if you are playing chess or some game, online game, while you are traveling. So what happens? Suppose how does that game really work? The game would be stored somewhere in the cloud, right? So it's the game. If you move the pawns, or if you move the pawn of the chess in the game, so there will be so many other people playing online with you, sitting at different places in the world. It can be different places in the world also. So how does that person know? And how if he moves in response to your move, that should also get reflected on your screen, right? That should happen in real time. Then only you will be able to play with him as if you are playing with him in front of you seamlessly, right? So for that, effective communication is really required. The system should know where to stream the data. So for example, if you are moving in a car, you can see it in the extreme left, right? Which is attached to a data center. Whatever the data you are generating, that will jump to the data center. From the data center, it will go to the cloud. We call that the smart data center. It could be a fog also, fog terminal. So the cut down version of the cloud. So the data should move to the fog and then to the cloud. And by the time you go to the other place B, which I have shown the extreme right, so that your result should also move there. Means the data center not only should know what you are doing, the data, it should also start tracking you. Means where you are really available. If it reaches the same old data center, then it has to again be streamed to the other data center in the middle of so many resources, right? There will be a lot of resource contention happening over there. So it should, your result should be made available wherever you are, to the data center close to you, so that the resources are effectively used. Here also artificial intelligence is being used. Next, coming to the automobile, probably you would have heard about how AI is used to catch hold when the driver is actually started browsing, right? Based on the face detection and eyeball movement detection, it should be able to warn the driver well in advance. When I say well in advance, a few milliseconds or a few seconds ahead before he really hits the obstacle. The moment he starts closing or browsing, the system can alert the driver. So that's also the face detection technology and eyeball movement detection technology, making use of the convolutional neural network, just I told, will be very useful over there. In-car multimedia dialogue system. In the sitting in the car, you can start giving commands to the different entertainment systems in the car. For example, you can ask the system to play certain movie of your favorite actor. The moment you tell that, it will immediately get displayed over there in the car. Or you can tell the movie to stop over there when you receive a phone call. It will be immediately paused over there until the phone call is really attended, and you are free to watch the movie again. The moment you put the hooks down of your phone, immediately it will start playing on its own. Such things are possible with artificial intelligence by observing all your activities. Next, let me tell about autonomous car. Probably you would have heard about autonomous car, where you don't even need to have a driver. It's a driverless car. So just all you need to do is just have to get into the car and sit over there. The car itself will drive you. It knows where you really want to go. Probably depending on the place where you are, and depending on the time of the day or the night where you are supposed to go. It will either you take you to the office, to the college, or to the school, or to your home, depending on the time. You don't even have to tell that. All you need is just have to get in the car and sleep. How is it possible? How does it identify the obstacles? That obstacle identification happens through one of the techniques is the CNN, whatever I explained. It has to identify and differentiate the objects. It will be a two-class classifier. It has to classify whether this is an obstacle or not an obstacle. If it is not an obstacle, it can go. Also, whenever a traffic signal comes, it has to identify the colors. When it is red color, it has to stop. When the traffic signal is green, it can go ahead. And if there is a zebra crossing, all these things it has to identify and learn the things individually and take care of the things. So in consumer electronics also, it has been used extensively. For example, if there is a spot or if there is a dirt on your shirt, then way to clean the entire shirt, only that part can be attended and cleaned. So the system should know where to see the things. And here is a vending machine. When I say vending machine, it is like your coffee machine. The moment the machine sees your face, it will give you the choice of your coffee, a favorite choice of your coffee, with the right proportion of coffee and milk and sugar, right? So how does it know? You would have set it once, and your face would have been recorded. The moment it looks at your face, many things can be done. And in fact, money can also be deducted from your pocket. So here is a dog watching the TV. Means you don't have to watch the TV like a dog or like an animal, right? Because the system would have learned like what you really want based on the eyeball movement and your level of interest and your facial expressions. If you are interested in certain, say, in local politics, or if you are interested in scientific information, all these things, then the system knows what type of information you are looking for, and only that kind of information can be streamed to you in a personalized way. It's as good as having your own TV channel, and exclusively for you, meant for you, because the ratios of the different types of information, be it politics or sports or cinema or whatever, that can be altered from person to person. And based on your eyeball movement, the system can know what you really want to know. Here is a fingerprinting. Based on the fingerprinting, fingerprint authentication is an important thing that can take place using a convolutional neural network. Among thousands of people, if one image of the fingerprint is given, the system will be able to identify it is you. Of course, next is the home automation. In home, suppose you would have forgotten to switch off the fan in third floor. All you need to do, you just have to scream, hey, third floor fan, get switched off in your local language, in whatever the language you want. It will get switched off. How is it possible? It has to identify the words spoken by you, and it has to map it to the devices at your home, and it has to switch off. Then, the moment you come in front of the garage, your car comes into the garage door should open, and it should open only for you. That happens through face detection technologies, right? All these things are possible. So in coming to the energy, the system should switch off the lights when you are really not over there. And of course, this is already existing. The moment you go, then you should switch on the lights based on the path you are going to take, right? That is already there. In healthcare segment also, it has to capture the vital parameters like blood pressure, then the pulse rate, and all these things. And it should be able to tell how your health condition would be on that particular day. It can even be able to warn you. That is the thing. Of course, in natural language processing, lot of things can be done. Summarization. So I spoke so much. You may be interested only in certain part of whatever I spoke. That can be extracted or paraphrased for you. Such things are really possible. Suppose you are interested only in language processing and not in the video processing. Such things can be separated out from whatever I spoke, and that things can be given to you. And sentiment analysis. You may be writing a big story, and then from the story, you should be able to extract what type of feelings you have. Right? That feeling can be in the form of words, in the form of facial expressions, like that. It should be able to find out. Then you have dialogue system. Probably you would have used or heard about Siri in your mobile phone. Right? You can ask questions. It will be able to do the things for you. You can ask for the nearest bus stop. You can ask for nearest restaurant. It will be able to give all these informations. And these things are possible with artificial intelligence. Then you can, I don't know if you are able to see all these things. Here is an important thing. This is a virtual reality. AI has enabled virtual reality. The moment you say, hey, show me the brain, here the doctor is actually showing the interest in certain part of the brain at the time of surgery. Hey, show me this part of the brain I want to see. He can easily see there or see it over there through virtual reality and get for additional information, go ahead with his work, right? Here, this is another virtual display. Moving forward, displays will be like that. Whatever you tell, corresponding displays will be generated. I mean, display events will be generated. This is an important thing which I will show you probably towards the last part of the talk.
Your mic 78. Your microphone is.
Yeah, this is an interesting thing. I hope you can see this. See here what this gentleman is doing. He's actually working in front of a machine. He doesn't have a machine actually. This is a virtual reality. And all he needs is he's a very domain expert. And the machine is there somewhere. Whatever the actions he's performing on the machine, that will be performed by a robot sitting over there. So you may be wondering how to handle the machine, especially during the lockdown time. So such technologies will be very helpful over there. Because for a software engineer, it's okay. He can sit at home and work. But for a manufacturing engineer, he has to go to the site, right? He has to go there, sit in front of the machine, take a spanner and fix so many things. But during lockdown time, can he go there? Or during the night, or during some time when he's not able to go? How to handle the situation? Here is the solution for that. Probably these things will be very helpful. Here, the virtual, as a part of virtual reality, is generating the image of the machine. He can fix the things for this virtual machine, which does not exist. A robot sitting on the site that perform the same job or the operations what he is performing out there. The same thing has been tried over telesurgery also. Probably sitting here, you can perform nano surgeries, especially for the heart, right? Even if it slips by a small or a nanometer, things will go adverse. You will be cutting something else. Instead of heart, you will be cutting something else, right? So that thing should not happen. So it will be very helpful over there. Then the other important thing is the brain computing interface. Just by your thought, in all these things, whatever it is, at least you need certain image or certain verbal communication. You need to tell certain things. But here, what happens is just by your thought, you can control the things. Every time you think about the same thing, same type of signals are generated by the brain that has been made used to exploit the things. For example, if you want to switch off certain, say a fan, then you just have to think about the fan. Same type of signal is generated by the brain. Then same that signal can be exploited and taken tapped out through your BCI devices, and that can be used to switch off the brain and switch off your fan through the actions of the brain or thoughts of the brain. So AI is also used in agriculture, farming, just to know the different types of soil and give the appropriate suggestions, moisture. Based on the moisture level, it can tell how much of water should be there. It is used in smart cities, for example, for parking lot. Just by using cameras, it can tell how many vehicles are stranded, where the vehicles are stranded, and how to route the vehicles. For example, if you go with certain speed, you will be able to meet the target and probably you can avoid the traffic congestions. All the suggestions can be given by the AI system, of course. And yeah, smart environment, it can detect the pollution levels. If the level is above certain thresholds or below certain threshold on some particular day, particular month, all these factors will come into picture. These things will be considered and appropriate suggestions will be given. And even during the disaster management also, for example, AI along fitted with the robots can be used for firefighting or used to handle the poison or the floods kind of thing. And even in retail shop, based on the consumer's interest, it will give recommendations to the producers, like what type of products will be running fast and at what type of places and the like. So in effect, artificial intelligence is effectively used in all walks of life. People have started to use it, and there are many more applications where we can really put them, probably with your thoughts and with your experience, and probably you can also put them into different projects and release many new application areas. Okay, thanks. If you have any questions, please, we'll have a few minutes to answer.
Sir, can I ask one question?
Sure, please.
I'm Atul Bhargav from Jaipur.
Yeah, hi.
Yeah, I'm into healthcare business.
Yeah.
We are doing NABH audits for hospitals.
Okay, okay.
So if I prepare an algorithm for audit system, I think it will be quite easy for all the hospitals because the standards are same. If I feed an input of the hospitals, I can easily come out with the gaps which are there without putting much of energy.
Okay, okay.
For these things, they take 2-3 months.
Okay.
I think this can be analyzed within I think within same day.
Right, yeah.
This is what I perceive in my kind of specialty.
Yeah, that will be really helpful. Yeah, we can make use of the advanced tools such as BERT and all from Google. It's an open source tool that can understand the language. Yeah, sir, language.
Just a minute. Which tool you are saying, sir?
BERT, B-E-R-T. BERT. BERT. Yeah, that is a powerful language processor that can understand the documents and organize the document. Probably you may have to write some more code over and above that. And then when your document is given from a new hospital also, it can be compared to the existing templates or existing phenomenon, and probably, yeah, you can make use of that.
Correct. Thank you, Sam. Thank you, sir. So nice.
Yeah.
Sir, just one more thing.
Yeah.
I think for education institutions, I think very useful in giving the results.
Right.
Yeah, you have certain percentages. You have a first division. You have a distinction and all that. The moment you put and you come out with the everything that need not calculate anything about that.
Yeah, yeah, a lot of things can be done for education institution. For example, even the machines can correct the answers, right? Suppose you
Correct.
would have each student can write the answer for the same question in so many ways, but all of them may be correct. But how does the machine understand that? For that, there is a mechanism for textual entailment.
Textual.
It's a yeah, this is an active research area. People are doing that. All the answer, if the intent of the answer, if the gist of the answer is correct, it need not be matching word to word. No need. It says if the concept, the summary of the answer is correct, matching with the
Correct.
what is supposed to be, then the person may get full marks. Accordingly, marks may be graded. If it is matching so much of marks can be given. If these important points are missing, then cut the marks so much. Everything can be given. Everything can be done. Maybe some research may be required over there.
Yeah, so I think the reinforcement is towards the change of professions and skills. I think there will not be loss of jobs, but there will be
Yeah. Good point. AI will not steal the jobs, but it will generate the jobs probably. Yeah, but it
yeah,
will be used for. It can be used as an additional thing. It doesn't. It should not replace the teacher. In fact, the teacher
right.
should. It will make the job of the teacher very well. Teacher can focus on something else also.
Yeah, they can reorient themselves and update their
Definitely,
technology. Yeah.
definitely,
Thank you, sir.
definitely.
So nice of you. Thank you, sir.
Yeah.
Thank you so much, sir. Thank you so much for
Thank
your
you.
presentation. Excellent,
Thank you.
excellent information you received, sir. Thank you so
Yeah,
much, sir.
good. Bye. Thank you.
So one more questions from audience. So
Yeah.
participants. Just a minute, sir.
Yeah. Sure.
The same question what you raised, no, sir. The sir asked, no. To what extent do you predict that AI will replacing jobs? How it started happening already?
No. AI should not
AI will
replace.
replacing jobs,
They will
employment.
not. Yeah. Sorry, AI will not replace. The goal of the AI is not to replace. It will make your life simple. AI. When I say AI is not 100% accurate. Even human beings are not 100% accurate, of course. Especially AI is used in many things where subjective decisions are taken. For example, judiciary. In judiciary, human intelligence is very important, right? The AI systems are also used for giving judicial verdicts. Just if AI system says hang him, you should not take him and put him into the gallows. That should not happen. Right? But it can assist the lawyer because these penal code exist. These precedents exist. The last time similar situation had happened, that time this verdicts was given, but information can be given to the lawyer. It does not steal the profession of the lawyer. Lawyer's life will be made simple. Finally, it's the lawyer who has to take the decision, and the judge has to take the decision.
Thank you, sir. Thank you, sir.
Yeah.
Sir, one more question, sir.
Yeah.
Can I ask, sir? Yeah.
Sure, please.
What is the most popular programming language used in AI, sir?
Python. Nowadays, it is Python, PyTorch also. PyTorch is predominantly popularized by Facebook. Python used extensively by many other open source community and also Google, right, and many other people. And Java is used as the next to this.
Yes,
And when
thank you, sir.
yeah, those are the languages.
Thank you, sir. Thank you.
Thank you.
Vaishali?
Thank you so much, sir. You have clearly explained the application and components of artificial intelligence. And you also explained the convolutional neural network, CNN, and image generation in detail. And you also gave a good example for reinforcement learning for our better understanding, sir. Then the things you have shared about the traditional machine learning and virtual reality on AI is very useful for us, sir. The topics which you shared with us today is really interesting and it will help us to improve knowledge on AI and machine learning. Thank you so much, sir, for your valuable time with us.
Thank you.
two most powerful warrior are patient and time. Now I request Rajalakshmi from MBA to introduce our honorable speaker, Dr. V. Mani to the people. Over to you, Rajalakshmi.
Thank you, Aishali. It is great honor for me to introduce and welcoming the fabulous speaker, Dr. V. Mani, to this pleasant morning. Dr. V. Mani, he is an Associate Professor, Department of Computer Science Engineering in Indian Institute of Information Technology Design and Manufacturing, Kanchipuram, Tamil Nadu. He finished his MTech in Computer Science and Data Processing in Indian Institute of Technology, Karapur, and PhD in Computer Science and Engineering in Indian Institute of Technology, Madras, Chennai. He specialized in Computer Science and Engineering. He had 16 years of teaching experience, 20 years of research experience. His research interests are image processing, computer vision, machine learning algorithm, and data structure, theory of computing, and he is a professional member in Indian Society for Technical Education. He served as a Senate member for about 5 years, STEAM coordinate for Computer Science and Engineering for about 5 years, faculty coordinate for Student Council for 5 years, SSQ equivalent to NSS coordinate for 3 years, Institute ranking in charge for 3 years, anti-ragging coordinate for 5 years, member of Computer Engineering Curriculum Designing Committee, Chief Warden for April 2018 to March 2019, and faculty coordinate for Computer Science Club since August 2018, and he published various journal and conference publications. Now, I would like to invite Dr. V. Mani to talk about overview of deep learning. Over to you, sir.
So good morning, sir. Masulamani, sir.
Good morning, sir. Can you hear me?
Good morning. Yes, sir. Yes, sir. Yes, sir. I am able to hear, sir.
Good morning to you all. Hope you're all able to hear me.
Good morning, sir. Good morning.
Yeah.
Yes, sir. Yes, sir.
Thank
yes,
you very
sir.
much
Able
for
to hear.
the long
So you are,
CV of mine. There are few things which are not relevant to the audience, but still, since you took it from my website, I didn't have any control over stopping or filtering. So sorry for some irrelevant things told to the audience. May I know how many participants are there now? Maybe
totally 104, sir.
104, good. Okay. How many are from
105?
Any information?
So many of them from outside participants, sir. Only the MBA students only 20-30.
Okay. So can I start now?
Yes, sir. Yes.
Okay. Is my voice okay, or is it breaking in between?
Yes, sir. It's audible. No issue.
Yeah. Right. Once again, good morning to you all. My talk is on the overview of deep learning. There may be some overlapping between my talk and what you just listened to the other expert member. Since I didn't know what is covered by other members, this overlapping, was not checked. So therefore, manage and accept that. This is more of a fundamental nature. Instead of giving lots of applications, I thought the basics related to deep learning should be taught in a precise way in a short time. So therefore, I chose this topic, overview of deep learning. The overview of talk goes like this. First, we look at motivation for an operation called convolution, which is used in convolutional neural network. And then we will see the operation convolution. Then we will see what was available before the advent of convolutional neural network, namely the feed-forward neural network. Then we will see the architecture of convolutional neural network. Then we will see several architectures following that CNN method. and doing nice image classifications. So what is the motivation for convolution? In a way, you can say convolution is a kind of a particular type of weighted sum. In engineering, you would have seen weighted sum having application in various fields, right? This convolution is a special kind of weighted sum. In other words, every weighted sum need not be a convolution, but convolution is a weighted sum. In what way it is a special weighted sum, we will see. Weighted sum will become weighted average when sum of all the weights in the window or matrix is equal to 1, right? Just we are connecting convolution with the averaging. So you can say that a special kind of convolution will become averaging, right? You know that averaging has got lots of application in engineering, particularly when you want to, filter out the errors in the sensor output. We need to, use this averaging. And this convolution, is acting as the tool even for doing filtering the noise in the sensor output. Let's see what is convolution. What is shown here is a special kind of convolution. You can see that there are two matrices given. This is one matrix. This is another matrix. First matrix is called as input image. Second matrix is called kernel or window. Many names are used: filter, kernel, window, and so on. Right. And what we mean by convolution of this image with this kernel or window is that you just keep this window or 2 by 2 sub matrix over here. This A is aligned with W, and B is aligned with X, and E is aligned with Y, F is aligned with Z. You multiply those aligned values, so you'll get AX here, BY, AW here, BX here, EY here, FZ here, and you add them up. And that sum is put here in the output matrix or output image. Right? Those who are new to image processing or imaging, just think that image is nothing but matrix, matrix is nothing but image. That understanding is sufficient to understand the whole lecture. Right. So therefore, I use the word image and matrix interchangeably. Next, for getting next value here in the output matrix, what you do, you move this window one cell to the right. So it will be put over BCFG and put value here. And then move one cell to the right, you will get the sum of products of the corresponding entries that will be coming here. So when you keep the window here, right, you are reaching the end of the matrix, right? You will not be able to move any further. Therefore, you will not go this side. So you need to come to the next element in the column direction. Right? Now you need to keep the window aligned with the portion here. Right? And you need to get the sum of products of the corresponding entries. So this is one particular kind of convolution, and the whole values are put here. And you can see that this window can be aligned with the submatrix, can be aligned with submatrices in how many places? Only in 6 places, right? And you get the corresponding sum of products and put into the respective cell in the output matrix. This output matrix is called as convolution of this image with this kernel, right? And the convolution is also called as image. You can also use the word matrix to represent that. Let us look at mathematics. So we understood the process of convolution, and we'll try to understand the mathematical expression representing that. Let us take I as an image, right? For those who are familiar with or not familiar with image, you understand I is a matrix, M by N matrix, right? And K be a window. Again, it is another matrix, normally of a smaller size than the size of I. The convolution of I with the matrix K or kernel K is the matrix S, where identity of the matrix S is Sij, and that is defined as this. How is it defined? Suppose you want the value when it is aligned like this, right? And what you can say is that for the input image I, the origin is this one. For K, the origin is the center of the window. So origin should be aligned. The origin of the matrix I should be aligned with the origin of the matrix K, right? And that time you multiply the corresponding entries and add them up. Why this limiting is from minus m by 2 to plus m by 2? Since we have taken center of the window as the origin, right, you can go m by 2 cells down, m by 2 cells up. Going m by 2 cells down is going in negative direction, going m by 2 cells up positive direction, like that, right? And similarly, in row direction, b by 2 cells to the right you can go, b by 2 cells left you can go. So that is how it is written. Why we take a symbol called flooring? This value of a and b should be integers, so therefore we are getting the integral part of this minus m by 2 or plus m by 2. And for finding ijth element, we are getting like this. So suppose we want to find next value, right? Then let's say 1 1 we already found. Now 1 2 we want to find, means put I equal to 1, j equal to 2, right? This formula will take care, and this is basically representing what we discussed just now. So what is special about this convolution? Yes, we understood the convolution is weighted sum, right? And for example, this you take as a window and place it here, and if you take the weighted sum, then you will get this pixel. Similarly, when you slide it and then take weighted sum, you will get next pixel and so on. So finally, the convolved image will be like this. What you see is the blurred version of the Taj Mahal, right? This is a blurred image. So this is basically weighted sum, right? And in a way, it is a scaled version of averaging, you can say, right? Averaging is a low pass filter you have seen, and you see the low pass filtering output here. But if you take a filter as like this, 5 here and minus 1s in the 4 places and zeros at the 4 corners, then when you convolve this image with this, you get this nice image, sharp image. You can see that edges of this image is not as sharp as this, meaning in the output image, edges are more sharp, isn't it? So we call this as the edge detection and filter. But in edge detection filter, in place of 5, we'll get 4. But when you add one more to that, then it is highlighting the edges, meaning sharpening the edges. So in these 2 examples, what I wanted to communicate is that using various filters, we can get a different task. Like we can blur it or we can sharpen it like this. And another example given here is to find the edges of this image, right? You can see the edge image is coming here, right? To get this kind of edge image from the given input image, you just convolve this input image with this filter or kernel or window, right? What you see in the middle is minus sign, everywhere else you have plus 1s, right? When it is applied on the homogeneous region, you will get 0. When it is applied, meaning when it is aligned with the non-homogeneous region, let's say at the top of the tower, when it is placed, and minus 8 will be multiplied with this, and the rest of the values will be multiplied with the background. They are very different. Therefore, we'll get different values. So on the edges, you'll get high value, because even if it is negative, it's high value because you will take the modulus at the end. So on the edges, it will give high value. The weighted sum will be high value. Off the edges, the weighted sum will be low value. We will see the other example, the detailed one. Suppose this is a touch band that we considered, and we take the window and keep it here, right? And the center of the window is multiplied with this pixel, and the rest of the pixels are multiplied in the neighboring pixels like this. And the sum of those products is taken here, right? And this is a second alignment, therefore the second pixel. Any queries?
Invitation.
May I request everybody to mute your mic unless you want to interact with me. You are allowed to interact with me even in between the lectures. Right. Otherwise, you can mute your mic.
Sorry for the inconvenience, sir.
No issue. No issue. I'll continue. Right. So you slide the window, right? Then you'll see the next pixel value coming here and so on, right? And so in this way, the number of pixels that you'll get here is the number of pixels that are there in the input image, right? Because we are assuming that the window, complete window, should be aligned inside completely. Part is lying outside is not accepted in this version. That is what we mean by without padding. We will not, put any extension to the image. We will not pad the input image, and when we don't pad, then the size of the output image is the same size as that of the input image. One more example is given here. So when you place your window here, and you just take the sum of products, and then you slide it and take the sum of products, and slide it, sum of products, like that. So this is the first possible configuration. It's the last possible configuration of the window aligned with the matrix. So in this way, here the input image size is 3 by 4. So therefore, the output convolved image size will also be 3 by 4. Let us try to extend to the generic one. Usually, image will be color image, right? In practice, nowadays, nobody is looking at the black and white or grayscale image for entertainment purpose, at least. So we need to look at how the convolution is happening for the color image. In fact, color image is basically involving 3 matrices. One matrix involving red pixel values. The other matrix will involve green pixel values. The third matrix will involve blue pixel values, RGB. So 3 matrices. In case of grayscale image, you'll have only one matrix that will give the light intensity received at every point. In case of color image, you will see 3 matrices. Right. So how we do the convolution for 3 matrices, we need to see. Earlier, we assumed that the input image is a grayscale image. Therefore, we work only with one image. Now we need to work with 3 images or 3 matrices, for instance. So what we do here, we define our filter as a 3D filter, right? Earlier we had a filter as M by N matrix or A by B matrix, right? Now the filter should be M by N by L, right? So width, height, and depth. So all 3 should be there. Usually the depth should be same as number of matrices that are considered here. So here 3 matrices are considered. Therefore the depth should be 3, and the width and height can be anything. But for practical purposes, we try to keep width and height are equal, like 3, 3 or 5, 5. And one more convention is that we need to keep the size of the width or size of the height as the odd number. The reason is that only then you will get the center alignment. Although in theory it is not a necessity, but for practical purposes, to make the filter symmetric with respect to the adjacent positions, we will make the odd size filters. Note that in this discussion, we will assume that the filter always extends to the depth of the image, right? For instance, in this case, there are 3 matrices, right? You should not have the depth of the filter as 2 or 1 or 4. It should be always equal to the number of channels or matrices that you got in this layer, right? So in other words, if you look at the output, you will see that the output matrix is a single matrix. Although input matrix is not a single matrix, there are 3 matrices involved in input, whereas in the output, there will be only one matrix, because in the depth direction, it is covering all the layers. Okay. Now let us look at some parameters related to the CNN, particularly the size of input, the size of convolved image, size of filters, and so on. Why we need to look at? That's an important question, not for academic purpose. Suppose when you try to train this deep learning models, right, the time taken for training the model is proportionate to the number of parameters that are involved in the model. So therefore, we need to know how many parameters are used in the model, so that we will understand that the training time that we are going to have is going to be more or less, right? Suppose you want to do the computation with smaller devices like handheld devices, like edge devices and all, mobile phone or Raspberry Pi or some edge devices. then you cannot have large model. The number of parameters has to be small. Therefore, you need to plan. Therefore, we need to know what is number of parameters. How to compute the number of parameters for a CNN is an important question. Right? Let us use the letters W, H, and D to denote width, height, and depth respectively. Right? What is height? Number of rows, right, in the input image is height. And what is width? Number of columns in the input image is height. What is depth? This direction. The number of channels or number of matrices, right, is called as depth. So the input image, the whole green color thing is called as input image, right? That is defined when the size of that is defined by 3 parameters: the height, width, and depth, right? Okay. Now the question is that can we use more than one filters? So far in all our discussion, we use only one filter. If you use one filter like this alone, then you will get only one matrix. Right? Now we use more than one filters, right? So to get more than one output matrices or images. Right? You may ask why? Why we need to use more than one filter? Many times, the students and also the researchers, will take some pre-trained model and they will do some retraining on extra examples, and without knowing why they need to do all that. Right? One quick question people will ask is this: why you have this many filters? Why not you settle with only one filter? Right? For example, in traditional image processing context, right, with only one filter, you cannot achieve many properties of the image. So, for example, you use Gaussian filter, right? You will only get the smoothened version of image. Suppose sometimes you want edges. Then in that case, you need to use Laplacian filter or Canning filter or Morgan filter or Sobel filter and so on, right? And so if you want to increase the contrast, some other filter should be done. So like that, for different tasks, different filters are required. In other words, to get different properties of the image, you need to use different filters. And therefore, we can do multiple filtering with multiple filters, right? And that's what mentioned here. And so the filter number is also be taken as one parameters, number of filters. And another parameter in CNN is the stride. What is stride? The half size, right? So far in the previous examples, the stride was kept as 1. Say, for example, here, first we align here, and then we align here, meaning we are making jump with one cell to get this, right? It was starting with A, now we are starting with B. So jump size is 1, half size is 1, right? And from here to here, the jump size is 1, right? The jump size or half size is called as stride. So in this case, stride size is 1. What is the problem with this jump size 1 or half size 1? The size of the convolved image will be larger, right? Larger means larger than what we may decide sometime. Suppose we want to reduce the size of the convolved image. What we can do? We can jump with more than one unit, right? Say, for example, instead of starting from B after this, you can start from C, right? You can make jump with size 2 or jump with size 3 and so on. Usually the image size will be very large, right? Even for a normal image of good quality that we use in day-to-day life, the size of the image will be 1 MB. In terms of number of rows and number of columns, it will be about 1024 by 1024, let's say. And that's a huge size, 1024 rows and 1024 columns. And if you make stride size as 1, then 1024 by 1024 number of times you need to do the calculation, right? The sum of products should be found that many times, right? And so the number of operations will be in GB, right? Meaning the number of operations that you did will be in the order of 2 power 30 bits, right? So that will be huge calculations. So to avoid that, what you can do, you can increase the stride size. Thereby you can have the smaller size that will have less number of operations. So therefore we introduce one more parameter called stride. So now what all we had? The width, the height, the depth, the stride, right? So 4 parameters we have. Right. Now let us look at this example. The white color portion is the input image. Now we introduce a new way of doing convolution, which is that you put zeros around the boundary. How many rows before the image and after the image you need to put? That is your choice. Let's say I put one row above the image, one row below the image with value zeros. Similarly, one column before the image, one column after the image with value zeros. Right. And this is called as padding with zero. Sometimes you can pad with the non-zero value also. You assume that we are doing now padding. Right. Now, if you do the convolution of this padded version of image with the kernel, then you'll be able to get a larger size. Right. Sometimes, for some application, the size of the input image needs to be kept as same as the size of the output image, the convolved image. For that, the previous definition of convolution will not be useful. You can see here, right? You can see here, the size of image here is, I think, 7 by 7. Yes, and size of the convolved image is 5 by 5. So the size of convolved image is less than the size of input image. Sometimes we may want to keep the same size as that of the input image. So in that case, we need to pad with zeros like this, and then you need to do the normal convolution. You'll get the same size. So what is the size of the input image? 5 by 5 only. Right. After padding, it has become 7 by 7, but before padding, 5 by 5. So you can see that the output image size will also be 5 by 5. Right. So that is called as convolution with padding. And how do you calculate this width? Similarly, we'll see how we can calculate height. First, we'll see how do you calculate width. What is width? The number of columns, right? Is called as width. And what is this F? The width of the window, right? So suppose you have 3 by 3 window. So width of window is F. So width of the convolved image is nothing but width of the original image minus width of the filtered or kernel or window plus 1. Right? You can see here. So let's say here 3 by 3 is the window size. So therefore F is 3. And 5 by 5 is the size of the input image. So W1 is 5. So 5 minus 3 is 2 and plus 1 3. You can see the output image size is 3. Like that. Similarly, you can also see for the height. What about depth? Depth, is kept same. Therefore, you will see depth 1. But if we keep multiple filtering, then the outputs of multiple filtering can be kept as different layers to make a new depth. And again, we need to talk about this P also. What is P? The number of rows that you have added before the input image. In this case, number of rows that you added before the input image is 1. Number of rows added after the input image is also 1. Therefore, number of rows added is 2p, right? Similarly, number of columns added is also 2p, right? And that can also be kept as another parameter. So you can see that the size of the input image is coming as size of the convolved image. And involving that p, how do you get the formula to find the size of the convolved image? Let's say the convolved image has got the width W2, height H2. W2 is nothing but W1 minus F plus 2P plus 1. And there's a typographical error. H2 should come to the next line. Okay. So what it, in the area formula, you can recall W1 minus F plus 1 was the formula. Now we add the P component also, 2P is added. So the number of P rows added here and another P rows added here. So 2P. So that is added. Right. H2 is equal to H1 minus F plus 2P plus 1. Right. So what it says is that if you pad with more number of rows, if you increase your width of the image, then convolved image size will also increase. Right. But if you increase the size of the window, then the size of the convolved image will reduce. Again, we have not used this stride number into account in this formula yet. Right. Suppose we make stride number 2, right? which means instead of jumping with half size 1, you have to jump with half size 2, which means you need to divide that with S. So W2 will be calculated with whatever W value you got divided by S. Of course, this plus 1 comes here because of that integer division calculation. And instead of plus 1 putting here, we put plus 1. We can verify that is coming correctly. Assume that the window size is odd size, 3 by 3, 5 by 5, 7 by 7, like that. Otherwise, this formula will not work. Right. So you can verify that. For example, if you take H1 is equal to 7, W1 is equal to 1, W1 is equal to 7, S is equal to 2. If you substitute these values, right, you will see that H equal to 4. How? W1 is equal to 7 minus F size is what? Right. It's not explicitly given. Let's. I think it's 3. So 7 minus 3, 4. 4 plus 2p, and number of p is 1, so 2p is 2. So if you divide that with S, which is 2, and add with 1, you'll get 4. You can verify the calculations. Right. Finally, the formula which is telling us the size of the output image. This is the output image, and this is the input image. Right. If the size of the input image is W by H by D, W1 by H1 by D1. The size of the output image, convolved image, is kept as W2 by H2 by D2. Then W2 is calculated with this formula. H2 is calculated with this formula. What is K? K is the number of filters. Right? If the number of filters is 1, then D2 will be equal to 1. So you can take this as an exercise. You can take this as an input size, 227 by 227 by 3 as an input size. And the window size is 11 by 11 by 3, and calculate the size of the output image. Right? Why we need to do all this? To find out, the number of parameters involved. Right? And if W1, W2, W3 are high, right? W1, W2, H1, H2 are high, then this will also be, high, and the model will have lots of parameters. You may have to learn a lot of parameters, and that will take more time. So, what is the connection between this operation and neural network? Right. So we are using this word CNN for about last 15 years, if not more. Earlier also, we were using this neural network, right? CNN is basically a kind of neural network, but we were using the neural network for a long time. Then what is the difference, or what is the connection? Let us try to understand that. In the traditional machine learning or pattern recognition, to recognize the image, let's say we want to check whether this image is of temple or something, right? Or monument or something, monument or bus or car or flower. We want to check given this image. For that, we need to take some features of it, some properties of this image. And based on that property, we will tell whether this image is representing a monument or flower or bus or car or something else. And for instance, you can take the edges as information of the image, and based on edge, you can tell whether it is car or bus or monument or something. Or you can take some important points called control points using some algorithms like SIFT or Hawk. And if the pattern of that control points, is denoting the car or bus or monument or flower, we'll say that that image is car or bus or monument or flower respectively. The point I want to make is that in the traditional pattern recognition or machine learning, we will look at the features of the object or image to classify the image or object. Whereas in CNN, it is not the case. We give the whole image as the input, right? Okay. But what the CNN does is that in between it is finding the features, right? Although the user doesn't give features separately, or the user doesn't have the headache of finding the features, he will give the input directly to the network CNN, and the CNN will find the features, apt features, and then it will classify. Right? So in other words, in traditional machine learning, there are two stages. For stage 1, feature engineering. Stage 2, classification. But in CNN, both are done together in one go automatically. So the user doesn't have any headache of doing feature engineering. Right? And you can see that in this example, you can see the features are the edges. And for this one, slightly different features are given here. The morphology of this Taj Mahal is maintained here. And using these things, you can tell whether it is representing a monument or not. Of course, the network should be trained efficiently. And another thing is that instead of looking at only one, in between image or feature image, we can have multiple things like this, right? And that is where the multiple filtering is coming. And you can use all this, right? And then you can transform this to another set of images in between, and then you can take the decision, right? And this sequence is called as convolutional network sequence. Then what is done in a normal neural network? We'll see this. Let us look at the problem of recognizing the digits. The digit may be 0 or 1 or 2 and so on up to 9. Let's say this is digit 2. And this digit 2 can be represented as a binary number, binary sequence. How? Wherever this 2 is crossing the cell, that cell will be represented with value 1. And if it is not crossing, then that cell will be 0. For example, 0, 1, 1, 0, 1, sorry, yeah, 0, 1, 1, 0, like that. So if 2 is present there, a part of that is present there in the cell, it is 1, otherwise 0. Right? Like that you can represent. So the 2D image representing 2 can be written as a 1D array of binary numbers, zeros and ones, right? So let us consider this is representing, this layer is representing the image of the digits. And in the traditional neural network, all these nodes will be connected to every single node in the next layer. Let's say this is the first node in the next layer. This is connected to all this, you can see. Similarly, the next will be connected to all this, like that. If there are m nodes here, n nodes here, m into n connections will be there between these two layers. And similarly, in the next layer, some k nodes are there, k into m connections will be there, which means the number of connections will be high. Who cares? Why it matters? You know, the number of connections is basically the number of parameters. If the number of parameters is very high, then the learning will take more time, and testing also will take more time, but that is not that significant. But the training time is huge, it will be enormous. So therefore, if you use a traditional neural network, which is forcing the dense connection, meaning every node in one layer is connected to all the nodes in other layer, other means the next layer is bringing too many parameters, and therefore we cannot afford to have more number of layers. So usually some 2 layers or 3 layers, maybe 4 layers will be there in the neural network, the traditional neural network, right? And if the traditional neural network has got, let's say 5, 6 layers, more than 3, right? People are saying that any neural network having more than 3 internal layers, right? In between layers is number of in between layers is more than 3. Then that neural network is called as deep neural network, right? But who tells that 3? Is it accepted by everybody? No. It's one kind of representation. But if you look at traditional, the conventional CNN or the recent CNNs, the number of layers is too high. Some 150 layers or 160 layers, even 200 layers are there, right? But you may ask, what is special about the CNN? Of course, the number of layers is more. Then you may ask, is it that the traditional CNN says that don't keep more than 3 layers? No, right? Over the last 30, 40 years, 50 years, right, we are using neural network, but nobody told don't keep more than 3 layers. If you do that, it is not neural network. Nobody is saying like that, but still we were not doing it. You know why? The computational resource was very limited those years, those time, some 15 years back or 20 years back. The concept of GPU, graphics processing unit, or the dedicated machine for AAML called deep learning engines, were not available some 20 years back, at least for the common man. Maybe it would have been there with research labs, big research labs, but not with the universities and the colleges, right? With the usual, the average researchers. So because of the advent of this high computational power through GPU, and today we are able to keep more than 3 layers, 10 layers, 20 layers, even 100 layers we can have, and therefore the CNN has become now very famous. And another reason why CNN has become very famous is that in those years the data were not available that much. Now because of the social media now, right, without knowing or with knowing, you keep pumping your data to the people who are gathering the data set, right? Somewhere you are saying yes, meaning you are agreeing to the guys who are collecting your data, but they will be offering some service to you, free service to you, but they will be collecting your data for research purpose, right? And that is how many of the data are generated. And nowadays people are also collecting their data and making it public for research purpose. And because of that, training with large number of data is also feasible. So therefore, to improve the accuracy, right, we are going for CNN. But if you look at traditional artificial neural network, one model called feed-forward network, there you can see that every node is connected to every other node. But in CNN, what happens is that to get one coefficient in the output matrix H11, you need to multiply and add for 4 components only, these 2 and then these 2. If it is a traditional neural network, then all these nodes will be connected to this node. Let's say this is the input layer, this is the first hidden layer, and all the nodes here should be connected to this one if it is the traditional neural network. But in CNN, only selected nodes are connected. How you take that selected nodes? We select the nodes such a way that the convolution is defined. How the convolution is defined? We have seen in the previous slides that you keep a window and multiply the corresponding elements and add them up. So the same thing is defined here, right? And for example, if 2 is here, when you keep the window here first time, you multiply this 4 elements and then add them up, right? And you will put the resultant here, right? Okay. And you will not multiply with any other elements to get this H11. Similarly, for getting H12, you only look at these 4 cells. For getting H13, you look at only these 4 cells. So like that. So what it simply says is that you don't have to look at all the pixels for getting the values. Now the question is that yes, in CNN we are not having full connection, whereas in feed-forward neural network, the traditional neural network, we have full connection. So full connection means we have more information, and the partial connection means we have less information. Yes, that is agreed. But because of the less connection, are we losing out too much of information? If that is the case, then CNN should not be a successful model. Right? If you look at this figure, you will convince yourself that although we are losing the connections, we are not losing the information much. Look at this G3, right? This is the third layer, this is the second layer, this is the first layer, right? To get this G3, right? Let's say we are considering with these 3 nodes in the previous layers. We are not considering the first node and last node. Fine. And you can see that H2 is computed using these 3. Right, and H3 is computed using these 3. H4 is computed using these 3. Right. So in the input layer, if you see, all the nodes are contributing to these 3 nodes. Right. In the next layer, you can see one node is getting contribution from these 3 nodes only. Right. But if you connect this G3 with these nodes, if you compare this G3 with these nodes, you see that all the nodes in the input layer are contributing to this G3 indirectly. That is where the benefit comes. Therefore, we are not losing out much information. Yes, some amount of information will be lost because of the sparse connection that is there in CNN, but not much, because every node here has information about all the nodes in the input layer, indirectly, of course, right? So therefore, the CNN has become a successful model. Again, that is told in different way. And the kernel 1 is operating, kernel 2 is operating, and both of them are taken together, right? And so in this case, 3 kernels are operating and they are taken together. Let us look at some traditional CNN, the very first CNN called this one, second, lean network. This is the very first CNN found to be working very well. And this has been used by many banks for processing their checks. And the check, some figures will be written, right? I'll start with this. In the check, the handwritten characters will be written. To recognize this handwritten characters, this model is used. The lean model is used. The model architecture is given here. Yeah, it's given here. The input image is taken into the pixels, right? And they are fed into the CNN. And here we have many channels, many filters are there. Therefore, many filtered outputs will be there. And then we introduce an operation called max pooling. What is max pooling? Max pooling is basically taking maximum of the values in the window, right? And then that is taken as an output. Again, we do the convolution that we discussed, and then again max pooling is applied. So again, the output is given to the next set of layers, and this is fully connected layers. It is basically the CNN layer. I mean, this is basically normal artificial neural network layers, fully connected. And then you have a classification layer, and in the classification layer, first we need to flatten it out, because this one will have 2D information that should be made to 1D. And then we will keep the output layer with the number of nodes equal to the number of classes that we want to consider. In this problem, we want to say the given image is representing 0 or 1 or 2 and so on up to 9. Therefore, you keep one node to say 0, one node to say 1, and so on, right? If this neuron fires with significant value, then it is 0. When this fires with significant value, it is 1. So, but the probability of 0 plus probability of 1, probability of 2, and so on should be 1, right? And therefore, if probability of 0 is very, very high, it's a 0.9, the rest 0.1 will be distributed to all this. So you will put a threshold to tell whether the particular output is corresponding to 0 or 1 and so on. Just now I told what is max pooling. For instance, suppose we keep 2 by 2 window, and you keep a window here 1, 4, 5, 8, maximum of that is 8, and then 2, 1, 3, 4, maximum of that is 4. So like that, we can keep a window over this. We can keep get the maximum. This is called as max pool layer. So in this architecture, there are 2 types of layers used. One is the convolution layer, which we just discussed, and the max pooling layer that we discussed here. Okay, now the question is that how do we train convolutional neural network? Right. See, what is given as input for training is that the input image and label. For example, I think I have somewhere here. Yes. So this image with label 3, this image with label 5, this image with label 3. So these are all given as input, and this you can represent in binary, and you can give 3 as input along with this to the model, and model will get trained. How it is get trained? The training method is same as the training method of traditional neural network, and that algorithm is called as back propagation algorithm, and error will be propagated to all the nodes in the neural network. Okay, fine. So the training, the error propagation, we don't need to be worried because it is already there in the literature in the traditional neural network itself. So only thing that we need to worry about is that the number of parameters that we want to learn. And here is one block diagram given. Suppose you have a max pooling layer. Once again, it's coming. Yeah, max pooling layer, and then flatten it out. Any question? You're flattening it out. What I mean by flattening it out is that the 2D or 3D matrix is converted into 1D matrix, right? And so 1D matrix means the column-wise matrix. And then the dense layer is given here, meaning you connect every node here to all the nodes here, and then dense node, dense layer, and so on. Right? The number of dense layers is limited, and only 3 dense layers are there. But there is no need of keeping all the 3. You can keep 1 or 2 or 3 as you wish, depending on your the computational resource. So this I already explained, and you can see how the inputs are specified. In the first row we have zeros, second row ones, third row twos, right? In other words, we say that which image has got which label. Image with 0 has got label 0. Image with ones has got label 1. Right? People will write 0 differently. Even the same person will write 0 at different time differently. So therefore, we need to give different ways of writing zeros, and so that is taken as input for training. So the architecture goes like this: the input image representing some character is given to the convolution filters, and then the convolution layer is giving the output, and that is going through max pooling. Output is coming here, and it is flattening. Flattening means you make it as a 1D, and then that is going through the input layers, the fully connected layers. Right. And this specific LeanIt, making use of this convolution layer and max pooling layer, was proposed, I think, in the year 2012, and it is one of the very famous model, used in the practice by bank. This is being used, and this is a relatively simple model. You can see that the input image size is taken as 32 by 32. If it is more, then it will be resized to 32 by 32 and goes through the convolution layer. How many convolution layers are there? You can see that the k is equal to 6, which means number of convolution layers is 6. In other words, number of filters is 6, right? And then again, number of filters here, max pooling will be 6. And then here k is 16, so the number of layers increases, and k is 16, number of layers is increased, and then flattened, and then it is going through fully connected neural network. So if you look at the number of parameters, it is not that high, right? It is reasonable, because the fully connected layers are only two fully connected layers are there. The number of parameters here is 48,000 plus, 10,000 plus, but number of parameters here very, very less, 150. No parameters to be learned here, because max pooling doesn't require, and 2,400. So you can see the difference between the number of parameters required for the fully connected layers and the convolution layers. Convolution layers require very less number of parameters, 150, in the order of 100. Whereas in the fully connected network, the parameters is in the order of tens of thousands, right? And therefore, you limit the number of fully connected layers, and you can increase the number of convolution layers as you wish. So all those things are again given in with the example. Various values of m, n, k, you get different numbers representing the number of parameters. And those who studied neural network might know that neuron will fire, right, in the biological neural network based on the amount of input that is received by the neuron. And to convert the amount of neurons input to the neurons output, some function will be used that is called as activation function, right? That is, biological activation function, looking at every biological neuron, is modeled in computation in different way. One way is that identity function, the input is output directly. The other way is that it is thresholded, meaning the step function is used, right? Beyond some threshold it is 1, till that threshold is 0, right? And some slightly changing value. See, if you look at the step function, it is changing very fast, abruptly, right? But many of the system will not work well if the changes are very abrupt. So we need to make it smooth. You can see this is mimicking the step function, but in a smooth way. It is also mimicking step function with more amplitude, right? And this is also mimicking step function. And this is also mimicking step function in a slightly different way, right? You can see here it is flat, but it is not flat, it is linear, right? So like that, the input value is converted into output value by this activation function, and they are all different models of defining the activation function. The question is that when to use, right? Which one? There is no answer for that. You need to look at the problem and find out, nature of the data that you work with, and then you define the activation function accordingly. For most of the cases, people found that ReLU function, rectified linear function, is working well. And there is a modified ReLU function also that is also found to be working well, right, for majority of the things. And another interesting thing in this direction is that there is a data set called ImageNet dataset, and the ImageNet dataset has got millions of images, 1.2 million images, right? And there are 1,000 classes, meaning 1,000 objects are there, right? And the challenge is that you need to classify the given image into one of those 1,000 classes. Meaning image may have boat, image may have sea, image may have human, image may have bicycle, image may have a scooter, car, like that. You may have to classify into that particular category. 1,000 classes are there, right? If your classification algorithm is able to classify this 1,000 examples correctly, classes correctly, then with high probability, your algorithm will work on classification on some other environment also. Right? Suppose the object is not belonging to any one of this 1,000 category, right? Still, it may work then. So that is why this challenge is very important, and they're conducting this challenge program competition for many years. I think from year 2012, and I think before that also it was there, but before 2012, the traditional machine learning algorithms were very effective. But 2012 onwards, this deep learning models are working well. Continuously from 2012 till 2019, no traditional machine learning algorithms are able to beat the CNN models or deep learning models. Therefore, for object recognition nowadays, people blindly go to this deep learning models because of their capability. So only thing is that we need to have large amount of data and good computation power. And the competition is named as ImageNet Large Scale Visual Recognition Challenge, ILSVRC. And I'm just giving you the outline of the performance of various classical networks and their performances. In 2012, the AlexNet is found to work very well on solving this classification problem of 1,000 different objects. And it was a very small network. In 2012, computation power was not that high. Therefore, we can understand that why they used small number of layers, 8 layers they used. And the error rate was 16.4%. Now, if you say that your error is 16%, nobody will consider, right? But those days, 16.4% for classifying 1,000 different classes was a great thing. So AlexNet was one of the earlier networks, CNN networks, found to work well on this challenge. Then the next year, ZFNet improved the accuracy a little bit further. The error rate is reduced to 11.7%, around 5% accuracy improvement was there with ZFNet. Then the next year, GoogleNet was able to reduce the error even further to 6.7%. You can see that the GoogleNet has got higher accuracy or less error by increasing the number of layers. Some extra convolution layers, some extra the fully connected layers, some extra max pooling layers. So they were brought like that, and they managed to increase the accuracy or reduce the error rate. And PGGN is also good one. It is a second best model in the same year. And the best thing is that although they didn't reduce the error rate as GoogleNet did, but you can see that BGGNet has used only 19 layers, but Google Net has used 3 layers extra. Therefore, you should also give importance to BGGN, because with less resource, it is able to reduce the error rate. Also, not as good as the Google Net. And next year, the tremendous change happened in number of layers. 152 layers were used by ResNet in 2015, and the error rate is reduced tremendously to the level of 3.57%. Right, so that you can understand. When you keep increasing the number of layers, there's a possibility of increasing the accuracy or reducing the error. So that is understandable. And what is good about that? They had a huge amount of computation resource, and they managed to do that. And in the next year, ResNet came in 2016. ResNet variant called Aicte variant, and that did not reduce the error rate, but they tried to reduce the number of layers, because to make the model useful to the common man who are not having a good computing resource. So they reduced 152 to 101 layers, and they got the accuracy of 95.9. Right, but you can see that the error rate is a bit more than what it was in the previous year. But still, the organizers of competition and consider this as a good work. You know why? If you could do it with less number of layers, good accuracy, if you get, fine. Even if you are not able to beat the best one, it's still fine. So if you are a researcher in this area, your focus should be not only on reducing the error, but also on reducing the number of layers. Thereby, you can make this model useful to the people who are having less amount of resource. And another landmark results came in 2017. There, the accuracy is increased like anything, meaning the error rate is reduced to 2.251%. This is still the best one, but with the increased number of layers, 152 layers. Right. So if you are able to have this 154 layers in your computing resource, then better SCNet, skews and skews net, right? SCNet, skews and exciting net, and that you can use. The same thing, whatever I discussed, put in the bar chart form. Nothing more. And so some more descriptions I have given here. So how many layers they used and all that. And the novelty that they brought in everyone. And the SCNet, skews and excitation is the novelty. Nowadays, when you make your own CNN and try to publish, the reviewers are looking at two things. One is the increased accuracy. The second thing, novelty. Right, so in every net that you learn or read from the literature, also you should know how the novelty is made. For example, in the SCNet made in 2017, the novelty is brought in terms of bringing a new block called skews and excitation. Similarly, in ResNet, the novelty is brought, by combining more than one models, right? And so in every model, some novelty is brought up. So that's it. I think I'm exceeding my time limits by 5-10 minutes, and I'll spend some 5 to 10 minutes for discussion. So the floor is open to the discussion.
So can I ask one thing?
Yeah, please.
So in case of telemedicine, we are using this AI. Sir, there especially in case of radiology, the images are in pictures, alphabets, numerical, and special characters. So are we using IVL, SVRC, which you told, or there are a number of layers we are using for that? Because for every feature, there has to be some parameter or some method to use.
Okay. So, yeah, what is your question, sir?
So what I'm saying, in case of telemedicines, say if you take example of COVID patient,
okay?
And we have multiple of CTs.
Yeah, multiple cities.
Patients, and we want to send somewhere for research purpose.
Mm-hmm.
The CT will have picture, figures means, then
Mhm.
alphabets.
Mm.
It can be numerical as well as special features.
Correct.
How
And
we
the
will how we will be which way or how we will be sending those uh, say images to the research
researchers?
fellow.
Okay. Yeah, in medical domain, there are lots of issues. You need to get the permission from the body related to that particular university or hospital for getting the data first. But technically, there is no much challenge. But this clearing the legal issues is the challenge. And technically, if you want to give a data set of images to researcher like me working on medical images, what you can do, you can upload into your Google Drive and you can share your link with me, and then I can download it. So,
but that data will be massive, no, sir? Because when we convert it to
other information you are talking about, right? The watermark information. So every image will have some text information, right? Like the patient name and when he got admitted, whether it is positive.
Correct.
Yeah, correct, sir. We can remove those things, sir. It's possible to remove that. It's called as, basically we are doing visible watermarking for putting the extra data onto the image. And there's a way to extract the watermark. So there's an area called, watermarking with reconstruction of original image directly. So you can use those techniques. So without losing
the compression of the data is first, I think, should be done.
Yeah,
because it will be massive data to and sending that massive data will not be possible just like that. So compression is required, and then it will be sent in the required form.
Yes, sir. That is, anyway, there's no image, no video nowadays is transmitted or even stored without compression. Say, for example, you store your image in your hospital in JPEG form. What does it mean? You are already compressed and stored. And suppose you are sharing your JPEG image with me through mail or through Google Drive. You are only sharing compressed image with me. But when I open it, since the decompression algorithm available in my computer is working on it, and it will bring back the original image directly. So the decompression is not a real issue. The real issue, as you told, the watermarking with the text, other information. And we can extract that, and then we can get the original image. Image part alone we can extract. That's a possibility.
Okay, sir. Okay, sir. Thank you, sir.
Welcome, sir. Any other query? There is no query.
No queries, sir. Thank you so much, sir. Thank you, sir.
Thank you, sir. Thanks for calling me and making me
No, sir, it's not.
Thank you.
Anybody is interested? One second, sir. Anybody is interested in collaborating with me on image processing, deep learning, image processing? You are welcome to contact me.
Sir.
Sir, can you share your email ID?
Sure, sir.
On chat, sir. Chat box, sir.
Yeah. Yes, I'll do that.
Because I am I'm enrolled with DRDO.
Oh, very good, sir.
Regarding AI and machine learning, and I'm a healthcare professional.
Okay, sir.
So researcher also, sir, in healthcare.
Okay, sure, sir. You will have.
Yeah, please share, sir.
Or can you please share your LinkedIn ID?
Yeah, I share my email ID. You can also visit my institute website, and you can search for extra details if you wish. More details are there in my institute website rather than
Great.
Yeah, shared, sir. Mozilla@IITDM.ac.in.
Yeah. Thank you.
Thank you, sir.
Thank you.
Thank you so much, sir, for your presentation this occasion. Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir, for giving this much extraordinary explanation about motivation for convolution and feed-forward neural networks and convolutional neural networks. This session is really amazing, and you have gave such a good examples. Thank you, sir. It just create much more interest to more about this session. Thank you.
Thank you all once
Now-
again. Have a nice day.
Yes,
Thank you,
sir.
sir. Thank you. So nice of you.
Now I request Bhavadharani from MBA to introduce our spectacular speaker, Mr. Kalfan Abdullah Al Masroori. Over to you, Bhavadharani.
Dr. Kalfan Abdullah Al Masroori, Associate Professor, the Dean of Muscat College, Sultanate of Oman, holds a PhD in Software Engineering in 2005 at the University of Manchester in UK and Master of Science in Information Systems in 1998 at the University of Leeds Metropolitan, UK, and Bachelor of Science in Computer Science in 1994 at Sultanate Qobus University, Sultanate of Oman. He has experience of 25 years in institution of higher education in the Sultanate, and his fields of teaching are software engineering, information technologies, and computer science. In addition to teaching, he took different leadership positions in different colleges such as Deans of the College, Assistant Dean of Academic Affairs, Head of the Department, Head of Session, Chairing Committees, and so on. His research interests are in many fields including artificial intelligence and education. Also, he received funding for research projects from the Scientific Research Council in the Sultanate. Now he is here to share about data science versus data analytics versus machine learning. Welcome you, sir.
Hello, very good morning to everybody. It is approximately 10:45 in Oman, and in India it is like more than 12 o'clock. So good morning and good afternoon. So let's say good every minute. Thank you very much for the organizers who did very well related to the organizing this event, and a special thank to Dr. Mohan. Okay, so let me share my screen. I hope that it is clear to you. So if the voice is clear and if the screen is displayed, just
Yes,
give
sir,
me
it's
please
clear.
a hint. Okay. So as you have seen from the agenda, I will go through some concepts, and then through these concepts, I will talk about the three things: data science, data analytics, and machine learning. Also, I will go deeply in the skills required and little related to the salary towards these three things, and what are the scopes related to the future and the future really in India for the data science. And there is also a rumor stating that is it possible for the data scientist to be a hacker? Okay, since we are talking about data, we are not talking about a normal data. We are not talking about an ordinary data. We are talking about a massive data, which is unstructured data. So just this screen displays some differences. For example, here from the left side, we are talking about a digital test, which can be sent through the devices. So is it possible to send the test? For example, if somebody like made some cake, or if somebody make some rice or something, some meal, is it sweet? Is it salted, and so on and so forth? Similar scenario for the digital smell. So also we can talk about the colonia. As you know, there are thousands of colonia available in the world itself. So how we can send such colonia and how we can send such tests between the machines. In addition to data, also to the unstructured data, we are having customer services. So as you know, in the customer service, as you have seen here, this is a robot available in Oman, in Muscat especially, and it is in one of the It is one of the canteen and one of the restaurants, but this restaurant is very special. So as you have seen, the customer service is working even not only for the robotics, also it works for the telecommunications. So if somebody is dealing and calling the telecommunications company like after midnight, as you know, the machine will answer. So how machine deals and treated with such information? Similar scenario, we have self-driving cars. So how data will be transferred between the car and between the surrounded area, for example, between the car and between the other cars, between the car and between the police stations, and so on and so forth. Here, the other example is the self-emotional. So as you have seen here, when we are talking about emotional, we are talking about deep learning, we are talking about neurology system, and so on and so forth. So as you have seen here, we can understand how this guy will feel. And also, we are having hundreds of examples related to the medical field, which we need a very unstructured data. So having in mind this instruction data, for sure that we want somebody to work on it, we need somebody to analyze it. Okay, if we started talking about the data science here, we are depending on the three circles. Okay, so data science mainly talks about data, and as you have seen, it covered three areas: hacking skills, math, statistics, and knowledge, and the required knowledge, which is related to substantive expertise. If we are talking about here hacking skills, mainly we are talking about how the machine can get these unstructured and structured data. So for sure here, we need machine learning in order to get this data, because some data will be available, and as you know, some data will not be available. So if data is not available, then we have to generate it, we have to predict it, and so on and so forth by using the machine learning. After having the machine learning, so data science also will have a knowledge about how we can analyze. So in this case, math and statistics knowledge will be needed. And similar scenario here, such brief ideas and brief knowledge about the science that which he is working. For example, if he is dealing with engineering, so this guy should have such information about engineering. If he is dealing with computer science, so such information is needed related to computer science. If he is dealing with medical, so such information is required related to the medical field. So as you have seen here, through the Venn diagram, which created by the Conway in 2010, we can understand the data science and the relation among the three big areas. Great. So what are the skills required to become a data scientist? Normally, data scientist deals with three areas: analytics, programming, and domain knowledge. So this guy should have a strong knowledge in Python, because he needs to understand the programming. So mainly in Python, this is the famous, as you know, that which is used in artificial intelligence, famous language. Some statistical analysis system, which is in abbreviation as SAS, RStudio, and Scala. These are the most tools that this guy needs to have such knowledge about. And also this guy has to have such experience in database and mainly in SQLY, because this guy will deal with retrieving and implementing the data itself. In addition to that, also this guy has to have some ability to work with unstructured data from various sources like video, social science, and the previous examples when I mentioned when I talked and discussed about the data itself. Also, he has to understand multiple analytical function. Why? Because this guy, he needs to understand how we can analyze the data. And finally, this guy needs to have some knowledge related to machine learning. Great. So after talking about data scientist, let's move to data analyst. As you know, data analyst comes under data scientist. So data scientist is the umbrella of many things. And one of these is data analyst. So data analyst is a person who can work and describe statistics. He can visualize data, and he can conclude and communicate the conclusion to others. Okay, again, what are the skills required for the data analyst? This guy should have, again, some knowledge related to programming, similar to data scientist, like Python, RStudio, and JavaScript, in order to know and to communicate between different programmings. Also, he should have some knowledge related to data processing and analysis tool, such as querying, data mining, data cleansing, and SPSS related to data analysis. SPSS is for Windows application, but as you know, there are other tools. For example, if we are using Linux media, so Linux, rather than using SPSS, we can use PSPP, which is similar to SPSS. Also, this guy has to understand some statistics and machine learning algorithms, such as probability distribution, hypothesis testing, regression analysis, clustering techniques, and so on and so forth. Even also, this guy has to have some knowledge related to data visualization tool, such as QLike Video and Power BI. Great. Okay, so here we are having a summary of the differences between data science and data analytics. So as you have seen here, when we are comparing between the four factors, so data science, the scope is macro, it is bigger than data analytics, which is micro. And the goal is, the main goal for the data science is to ask questions, and the main goal for data analytics is to answer this question, which will be asked by data scientists. And here there are some examples related to measures. So data science can deal with machine learning, with artificial intelligence, search engine, corporate analytics, and so on and so forth. So you are noticing here the data science will lead or will know the general topics, while the data analytics has to have some deep knowledge related to the, like, for example, healthcare, gaming, and travel. And both of them are using big data. So as a general, data scientist will create questions, while data analyst will find the answers to these kind of questions. Great. When we are talking about machine learning, and as you know from previous my friends' talks, a summary, machine learning can be defined as a practice of using algorithms to extract data, and this machine will learn from this data in order to protect and to give such solution for a specific topics. Here we are having such examples. Machine learning are implemented in many areas, and I gave very famous and the new trends currently. For example, the Facebook machine learning, and as you know, even also when in the meantime Facebook, as you know now, is taking care of WhatsApp, Instagram, and so on and so forth. So Facebook is gathering and compiling all information from all surrounding area, and after that, this algorithm will gather the behavioral information from every single user. And after that, we'll analyze this information. And based on the past behavior, which is already compiled by this algorithm, the algorithm will predict the interest, and the recommend article and notification can be displayed in front of the user. So this is the reason why if a person normally is searching through a specific, for example, requirement, then after login to the Facebook, immediately the news related to that search will be displayed in front of the eyes of that user. Another example is Amazon. And as you have seen that if a person or if the buyer normally is searching for a specific item, then the behavior will be recorded. After that, it will be analyzed. And as you know that it will be recommended, the product itself will be recommended to the person. Similar scenario for the Netflix, and Netflix related to, as you know, videos and based on what the required person normally is moving and watching, what kinds of movies, then Netflix will display and will give such suggestions to this guy. Okay, what are the skills required to become a machine learning expert? There are many skills, to be honestly here, because when I read, I notice many things, but here just only a brief examples. So this guy should have such knowledge related to computer fundamentals. This guy also, he should have some knowledge related to programming. In some areas, this guy needs to have some deep knowledge overall, because as you know, this guy should have a general knowledge about the areas, but deep knowledge about a specific area. So basic knowledge in math and calculus. Why? Because this guy will work with statistics at the same time. And also this guy will work with the probability and data modeling and evaluation skills. If we are comparing between data science and machine learning, so as you have seen that data science works as a multiple discipline. Okay, so the gray circle is a data science, while the surrounding area are coming parts and partial belongs to the data science. So here, data scientists should have a knowledge about statistics, pattern recognition, machine learning, data mining, database and data processing, and visualization, and so on and so forth. So machine learning fits with the data science. If we are talking about the salary itself, so here, based on the glassdoor.co.india, okay, I checked the updated figures related to February 2021, the salary in United States. So I compared here. There are two tables. The left side table talks about the average of salary per year related to the three fields: data scientist, data analyst, and machine learning engineer. Okay, so as you have seen per year, for the data science, the average approximately will be 113,000 per year, while for data analyst is 62,000 per year, and machine learning engineer is competing with data scientist, which is 114,000 per year. In the right side, there is a table. Just I took some examples from the famous companies, and I made some comparisons again between these three areas in Facebook, Oracle, IBM, Google, Microsoft, and Amazon. So as you have seen here, the data scientist again is competing with machine learning. So the average here, data analyst is in between. So you can notice that Facebook is 130, while machine learning engineer is 160,000. Here is 111. Okay, IBM is 135, 41, and 111 thousands per year. So overall, the data analyst is in the middle layer, and it is in between data scientists and machine learning. But overall, if we are comparing between the salaries among these people, the three areas and other fields, we can notice that data scientist is having a very big trend. Okay, a future scope of data science. Data science, currently it is called as the sexiest job of the 21st century, which is in this century. Who said this one? Is Harvard Business Review. And there are many reasons why data scientist is the current job. Okay, first of all here, inability of handling the data related to the companies, because we are having a huge amount of data, as you know, generated every millisecond and transferred between the devices. So these companies will face some difficulties in order to handle data. So this is the reason why we need data science. The second reason is revising, as you know, the privacy rules and regulations. As you know, the GDPR, which stands for General Data Protection Regulation, was issued by the European Union in May 2018. Another regulation was issued by California 2020. And as you know, this will create the codependency between the transferring of data between the companies related to sharing accurate data. So in order to take care of the privacy, such rules and regulations are generated. Why also we need data science? Data science is constantly developing. So as you know, it is rapidly developing. Every time jobs, as you know, are newly created and newly added, especially related when we are talking about artificial intelligence. So new specializations and new majors will be generated related to artificial intelligence fields. Another reason is the amazing rise in data growth. So as you have seen, as I said before, the data is growing up rapidly in a lightning speed. So it is very difficult to deal with it and to control it. Virtual reality will be more friendly since we are talking about reality. So as you know that we are discussing the virtual reality and augmented reality. So we started last time, and there are many projects even here in Sultanate of Oman. We are working on this area, and the projects are growing up in a massive way. In addition that, human and machine, as you know, are interacting with each other. So a dependency and improvement of the friendship between the human and machine should be improved more and more. And as you know, since we are talking about transferring of money, so we are talking about the blockchain. So as you have seen that blockchain, again, also it is being increased. And once we are talking about the blockchain itself, so we have to take care of the security related to data transferring. Here just I did ask a question related to the future of data scientists in India. Okay, so based on upgrade.com, website, data science is one of the most demand jobs for 2021, and it is predicated that by 2026, data science and analytics would be having more than 11 million jobs. Wow. We can notice that many jobs will be created within these 5 years. And India normally comes after United States. This is based on the upgrade.com. So many jobs for data scientists will be generated in a short time. Okay, a very big question was raised. Okay, can data scientists become a hacker? This is a strange question. Why? Because, as you know, we are depending on data, and since we are depending on data, so machine learning will work here. And since we are talking about machine learning, so in this case, data will be combined from anywhere, and data can be predicted, data can be generated. So the answer is yes. Data scientists can be a hacker, and even also when I read many writers, they are stating the same term. For example, here, Hilary Mason said that data scientist is someone who can obtain, scrub, explore, model, and interrupt data, and blend hacking, statistics, and machine learning also will occur. A conclusion of my presentation is data science, data analytics, and machine learning are some of the most in-demand domains in the industry right now. Another conclusion, general conclusion, is a combination of the right skill sets and real-world experience can help you secure a strong career in these trend domains. Okay, so this is the last slide of my presentation. I made it short, and if there are any questions or clarification or input from my colleagues, you are most welcome.
Sir, can I ask one question?
For sure.
Yeah, I'm from healthcare. I'm from India. I'm Atul Bhargav from India. Sir, which specialty in healthcare you feel the maximum demand will be there of artificial intelligence and machine learning?
What do you mean by which? Are you talking about which part of artificial?
Yeah, because which specialty you feel in healthcare? Healthcare is a very big field.
That's true.
Like telemedicine, or like maybe robotic engineering, maybe any other field which you feel the maximum increase will be there, the usage of AI and machine learning.
What I am believing, that I am believing mostly the expert system will play a role here, because expert system is like mimicking the real doctor. So expert system is one of them, and even also a robotics. Why? Because it can help a doctor in order to do the operation. So both fields, expert system and robotics.
Okay, sir. Thanks.
You are most welcome.
Hello, sir. I have one question actually. Can I ask?
For sure. You are most welcome, sir.
So I am working as a data scientist in Hyderabad, and so I have a question: how we can leverage the power of data science during the COVID area? Like we have ongoing COVID period. So how we can leverage our data science skill to for the social benefit or for the social goods?
As you know, here, COVID area, everything is working as online. So even also in the colleges, in the universities, and even also between time to time, some countries, they started even also using online medical system. So since we are in COVID and everybody is isolated, as you know, artificial intelligence and data science will play a good role in dealing, as I mentioned here in the first slide when I discussed about the data itself. The digital smell also can be communicated. The digital test also can be communicated. So since we can send the smell and we can send the test at the same time, also we can deal with other things very easily, especially when we are talking about also the social media, because social media is a matter of data transferring applications. And as you know, in order to analyze the massive data transferred between these applications, data scientists will play a good role in the social media application. I hope I understood and I answered your question.
Yeah, that was very insightful actually. Thank you so much.
You are most welcome.
Thank you.
Yes, is there another question? Okay. Okay.
I think
Thank you, sir.
the connection get disconnected.
No, sir. It's a connection, I think so. Hello.
Okay. Yes, I am with you.
Okay, sir. Thank you so much, sir. You explained a lot about this program. I think you just connected from Woman. Thank you. You explained a lot about the data science versus data analytics versus machine learning. Thank you so much, sir. You enlightened the speech. Thank you. Really, thank you, sir. Thank you.
You are most
Any
welcome.
questions?
Thanks.
Is there any questions you can ask the audience? Any questions?
Even also, I mean, it can be communicated through email. So,
yes.
So
you can share your mail
we
ID.
can work together.
You can share your mail ID.
Okay, I would.
So definitely,
okay.
If the participants have any doubts or any queries, they can share your doubts with through mail.
Okay, shall I write it in the chat or where exactly?
Chat, sir. Chat.
Okay, just a minute, please.
Yeah, sir.
Okay, this is my email.
Thank you, sir, for this informative session. You have clearly explained about data and what are the skills which we have to acquire to become a data scientist. And you made us to be clear about data science and data analyst. And you have touched upon an interesting topic, machine learning, with some good examples. And today you create an awareness about the scope of data analyst and data scientist. Thank you, sir, for this wonderful session.
You are most welcome. Thanks indeed.
Thank you so much,
Thank
sir.
you, sir.
Thank you, sir.
Ladies and gentlemen, now this is the time. Let's break for lunch. I request all the participants and attendees to join the conference meet sharply at 1:55 p.m. Thank you.
Thank you. So, at what time this workshop will end today?
Sir, it's end 5 o'clock, sir. 5 o'clock.
Okay. So
Yes.
I have to rejoin at what time?
2 o'clock. It's 1:55. 1:55.
1:55. Okay. Thank you. Thank you.
Three more session is available. So 2 more session is available. The time
Yeah,
is 2 to 3, then 3 to 4. Then
Yeah.
the validary, the 3 more guests is going to join. One is Dr. V. Ajit Kumar, Vice Chancellor, Skyline University. Dr. Navin
Yeah.
Sheth, Vice Chancellor, Gujarat Technology University. Then Mr. Sanjesh Mushi, Lead HR, Oracle.
Great, great. So earlier, when I registered for this event, so it was saying it is a 2 days event. So
Yes, sir.
right now it's 1 day, just for 1 day, or there will be another
No,
session.
sir, it's a 2 days event. Yesterday we completed. Today is
Okay.
another 1 day, sir. Second day.
Yeah. Okay. Thank you.
Thank you so much, sir. Thank you, sir.